Hello, today we are going to be going over Unit 1, Lesson 8, Measuring Angles Part 2. Your learning goals for today are define angle pairs, measure and classify angles, identify and use the angle addition postulate, the angle congruence postulate, and the linear pair postulate. If point Y is in the interior of angle XUZ, then the measure of angle XUZ plus the measure of angle YUZ equals the measure of angle XUZ. Okay, so if I were to highlight this to show you, I would say, so it would be this angle measure, I'll underline it, change my color, plus this angle measure, I'll underline it. When you add those two together, you get this angle measure. Okay, so that's to kind of help you color code. That's the angle addition postulate. So let's go ahead and go over an example of it. It says, what is the measure of TQR? So let's look at what we have. Well, we have that TRS is 30. We have the SRQ is 15, but what we want to know is angle, let me get my highlighter, we want to know angle TRQ. Okay, so we learned from our angle addition postulate that all we have to do is add those two things together. So we're going to say 30 degrees plus 15 degrees is going to give me 45 degrees. Okay, now let's look at the other one. Okay, this one, it's not labeled here, but we can go ahead and label that. So let's start with each little piece and label as we go. If the measure of ABD is 38, and the measure of DBC is 42, what is the measure of ABC? Again, all we're going to do is add these two things together. So 38 plus 42, add those together and you get 80. We're measuring angles, so we measure them in degrees. Let me go back up and put my degrees right there too. Alright, let's try another one. Okay, so let's see. This one's going to be a little bit different. It says, what is the measure of angle CBD? So let's go ahead and highlight CBD, because we know this is the guy we're looking for right here. Okay? Then it says, if the measure of ABC is 140. Okay, so ABC is right here. This whole angle is 140. And we know that this section is 65. Okay, so we're going to kind of work backwards, but I'm going to go ahead and set it up as an equation for you so that you can see exactly how we're using this angle addition postulate. Okay, so I'm going to say, all right, the measure of the angle that I don't know, so CBD, that's the one I'm looking for, we're going to call it X, and I already labeled it, plus the measure of the other angle that's given, ABD, which is 65, is going to equal all the angles added together, which is 140. Well, we're solving for X. Draw a line down from your equal sign. This is algebra. Subtract 65 from both sides because we do the opposite. Okay, so 140 minus 65, you have to borrow from the 0, make that 10. That changes to 3. 6 can't go from 3, so you borrow from the 1, make that 13. So then we have 10 minus 5, which is 5, 13 minus 6, which is 7, and don't forget degrees. Alright, moving on. There's quite a few slides here, so I'm going to try to keep going so I don't make it too long for you. Okay, next we need to identify adjacent angles. They are angles that are in the same plane, they have a common vertex and a common side, okay? So they're pretty much, you could say, adjacent angles are side by side. They're always going to share. Adjacent angles share. They use the same vertex, they use one common side. Okay, so if I were to just, well, actually, I've got an example on the next one I'll show you. Okay, so it says name two pairs of adjacent angles, and I'm going to identify these with my highlighters. Okay, so first I'm going to look at this line segment right here. Okay, the two adjacent angles from this line segment, I just look to the left of it and I look to the right of it. Okay, so the angles here would be angle APD and angle DPC. They share line segment DP and they share vertex P. Okay, now I'm going to switch highlighters and I'm going to look at this one right here. Okay, and I'm going to name adjacent angles for it. And this time I'm going to use a pen color of green. So let me select that. Okay, so I've got my angle DPC right here, which is going to be adjacent to angle CPB. Okay, they share the common vertex again, and they share line segment CP. You can see the line segment CP is listed right there. That's adjacent angles. Okay, angle pairs. We have two types of angle pairs we're going to talk about first. That's complementary and supplementary. Okay, complementary angles, they add up to 90 degrees. Okay, so complementary are two angles that add up to 90 degrees. Supplementary adds up to 180 degrees. Okay, a way that I've seen students remember this, okay, when you spell out complementary, my pen sometimes doesn't want me to do it, complementary, my pen keeps taking it away from me. When you draw a line down from the C, it makes a 9, so that's 90. Okay, and this is just kind of a trick to use. And then supplementary, okay, when you draw a line through the S, it makes an 8. Add the 1 and the 0. Okay, that's the only kind of trick that I have for you to remember it. Is 90 is complementary, 180 is supplementary. Okay, then we have a linear pair. Okay, it's a little bit different than supplementary. It makes a straight line, which we know is 180 degrees. But they have to have a common side. Whereas supplementary, they can be located in two different parts as long as they add up and equal 180. Okay, so if you look right here at this picture, okay, it shows that angle 1 and angle 2 equal 180 degrees. They are supplementary, okay, because they do equal 180 degrees, and they lie on the same line. Okay, so a linear pair is a pair of angles that make a line. Okay, they make a line, and then we know from some of our previous lessons that a line is 180 degrees, and then we know from just the previous slide that 180 degrees is supplementary. Okay, so we see how they all connect in with each other. Okay, and then here's our linear pair postulate. If two angles form a linear pair, then they are supplementary angles. And we're going to use that in proofs later on in the future. It says identify the type of angle pair. Okay, so let's look at the first one that is yellow. Well, I've got angle 1 and angle 2. Okay, they stretch that far. Okay, they make a straight line. Okay, two angles make a straight line. Well, first off, I could say, well, that's a pair of angles that make a line, so that's going to be a linear pair. But then we also know from the linear pair postulate that if it's a linear pair, they are also supplementary angles. Okay, next example, the green one. Okay, we've got 25 and 65, so we want to know what this angle is right here. Well, we add them together. 25 plus 65 is going to give me that magic number of 90, and 90 is complementary. Alright, so in conclusion, adjacent angles are in the same plane, have a common vertex and side, and have no interior points in common. That is, the angles do not overlap. If you add the measures of two angles and the sum is exactly 90, they are complementary. If you add the measures of two angles and they are 180, then they are supplementary. A linear pair of angles is formed of an endpoint of a ray and is on a line that are also created. And also, let's add to that they are also supplementary. Alright, thanks guys for watching, and I'll talk to you in the next video.